Hi, pre-calculus. This lesson is going to go over graphing with transformations and how to write equations of trig functions. Here's a couple of steps that we're always going to use, and we're going to do these in order. Okay, so the first thing we should always do is figure out the period of the trig function, and then the section, which breaks down the period, and then of course label the x-axis. So we do everything horizontally first. Okay. The second step then is we're going to figure out the shift up or down. The shift up or down, and then what that does is it kind of tells us where the middle is going to be. Where's the middle of the graph up and down from the x-axis? The third thing we'll do is figure out the amplitude, if it has amplitude. Okay. So then, how high up, okay, and how high down does the graph go? So then we have our high and our middle, and our low. The fourth thing we'll do is figure out the phase shift. Okay, so the phase shift is how you shift left and right. It's shifting left and right, but because it's periodic and it keeps repeating, it's not like the vertex is now to the right. It's just that the whole graph shifts left or right. And then, of course, you have to ask yourself, how does it start? How does it start? Okay? How does the sine graph start? Think spaghetti, right? So for this first example here, let's go through our steps. The first thing we'll do is we'll figure out the period. This is our A value. Our B value is right outside the parentheses. That's a 1. We've got our C value, and then we've got our D value. The B value helps us figure out the period. And so the period is going to be 2 pi over 1. And then the section. So this is unofficial. Let's just add a little column here. The section would be taking the period and dividing it by 4. So that would be pi over 2. And then let's label the x-axis using this information. So we've got an x-axis, I've got our y-axis. Let's go ahead and put 1 out of 2, 2 out of 2, 3 out of 2, 4 out of 2. Going negatively, negative, 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 negative. Okay, we've got our x-axis and all the horizontal numbers listed. Now we're going to figure out our shift up and down, and that would be the D value right here. So this graph shifts 3 units up, so let's make sure we put 1, 2, 3. Okay, make sure you put 3 tick marks, and that is where the middle is going to be. So if you just want to label this middle, go ahead. Instead of hovering up and down over the x-axis, we're going to be using this middle right here. Okay. The third thing would be the amplitude. The amplitude, how high up and down does this graph go? The amplitude is 5. So this is our middle. Let's make this look more like a 3. If our middle is at 3, okay, it's going to go up 5 units. Up 5 units, and then it's going to go down 5 units. So how high does it get? 3 plus 5, it goes all the way up to 8. 4, 5, 6, 7, 8. This is 8. I'm just going to go ahead and put a little dotted line to make sure my graph gets up to 8, and then it's going to go from 3 down 5. 1, 2, 3, 4, 5, as low as negative 2. Okay. What I want you to make sure you're aware of here is we've got our high, we've got our middle, we've got our low. Okay. At no point, okay, should we be using this x-axis as any special feature. We're going from high to middle to low, and we're not stopping on the x-axis. You have to make sure you don't do that. Okay, we've got our amplitude. Let's do our phase shift. Okay, so does this graph shift left or right? And it's going to shift left pi. It's going to shift left pi. Okay, so here's where I'm just going to put a little highlight on that value. And how does it start? How does the sine graph start? Well, sine always starts in the middle. Okay, always starts in the middle, so we have to make sure we hit the middle. So get up here to 3. But since it's negative, it's going to start going down. Okay, so we've got to make sure we hit either high, middle, or low, and not the x-axis. A negative sign is going to start going down. So at negative pi over 2, we're going to be at a low. At a low. At 0, we'll be at a middle. Pi over 2, we're going to be at a high. At pi, we're at a middle. 3 pi over 2, we're at a low. Then we're at a middle. Let's go the other way. If this was middle, negative 3 pi over 2 is the high, and then back down to middle. When you draw your sine graph, okay, we're hitting high, middle, we're hitting low, okay. Did we hit the x-axis in a special place at all? No, not really, okay. He does have an x-intercept, but notice I'm not going to ask for the zeros because they're really hard to find. We'll have to solve those algebraically. High, middle, low, middle. Okay, did we get 2 periods in? Up, down, down, up, down, up. We did. The amplitude for this graph was positive 5. Don't say the negative. The domain for this graph, he doesn't stop. He's continuous, all reals. The range goes from as low as negative 2 and as high as 8. Okay? Remember, when you're shifting up and down, it's not necessarily same number, same number. And there are no asymptotes for a sine graph. He is continuous. All right, let's try another one. Let's look at a tangent graph that has some phase shift. The first thing we'll do is maybe label all our numbers. So we've got a negative 1, that's the A value. The B value is out in front of the parentheses. We've got a C value and no D. So the period for tangent, what's the tangent formula for period? Okay, so the period is pi over B, which is just pi over 1. And then what would the sections be? How many sections do you divide a tangent graph into? Yeah, we divide them up into 2 sections, so that would just be pi over 2. So after you get your x-axis values, let's go ahead and make our x-axis. So we'll have 1 pi out of 2, 2 pi out of 2. And we'll go the other way. Now you can always do extra graph if that helps you. Sometimes people don't like having a little half of a tangent graph. They like to finish it off, or they don't like to leave the sine curve kind of hanging. They like to bring it up to the middle. You could always do extra. Okay. Let's see. Where were we? We did our period. Is there any shift up or down? No. Tangent doesn't really have amplitude. He would have some stretching. I don't believe he does. So let's go to phase shift. We're going to shift pi over 2 which way? Pi over 2 to the right. Okay, so here's where we're going to start on pi over 2. And does a tangent graph start with a point or with an asymptote? Tangent starts with a point. So this would be a point, an x-intercept, and this would be an asymptote. Asymptote, point. Asymptote, point. This point didn't need to get shift up or down at all. We just got phase shifted to the right. Oh, and don't forget about this negative. This negative. So a regular tangent graph, tangent usually looks like this. So I'm going to reflect it over the x-axis, and I'm going to make sure that it's going down, down, right. Okay, so let's approach the asymptote here. Make sure you touch the 0 and approach the asymptote. Get close to the asymptote, really close. Do not hover in the middle. Take a look at your hands. Does your graph get close to your hands? If you're drawing really wide sections, then you have to draw your graph wide. You have to approach this asymptote. Okay, there's 2 branches, so I've got the 2 full periods. Domain for tangent. There are clearly a lot of breaks. Okay, so there's all rails except where is the first break in the graph? You look at the x-axis. If it happens at 0, great. If not, you go to the positive one. So we do have one at 0. There is no graph at 0. And then the distance to the next break in the graph. The distance to the next asymptote is pi plus or minus pi n. The range for tangent, he goes as low as negative infinity and as high as positive infinity. Where are the asymptotes? It's the same place these breaks were. The first asymptote is at 0. The only difference is this was no graph and this is equals. The asymptote is here, plus or minus pi n. And does this graph have zeros? It does. It does have some zeros. Where is the first 0? You always want to make sure you state the positive one. The first 0 is pi over 2 plus or minus. Where's the next x-intercept? Well, it's not there. It would be here. It would be 2 sections to the right. There's the next one. Or minus 2 sections to the left. Okay, so it's clearly 2 sections. What's this space that's 2 sections? I know, I'll just go over here, slide my fingers. The distance of 2 sections is pi. So pi is the space to the next one, pi n. Are you writing x equals? Do you have plus minus? Do you have your n? Okay, so that's how you do all the transformations for the different graphs. Let's take a look at how to write an equation. Okay, so sometimes the writing is going to get a little fancier when you start adding in all these phase shifts, right? Write the equation, okay, and the problem tells you if you have to make a sine, a cosine, a secant, what kind of trig equation to make. So for number 3, we have to write a sine graph. Okay, and there's a couple of things we're going to go through. The things that you have to figure out, you have to examine. You have to get the period. You have to get the amplitude. You have to get the phase shift. And then you have to get the vertical shift. So the kinds of shifting are the phase shift, left and right, okay, and then the shifting up or down. Okay, so let's take a look at all these. A period for a sine graph would be 4 complete sections. Let's see, down, down, up, up. Okay, so this right here is 1 complete period. And the time it took to do that was 2 pi. Okay, so the period is 2 pi. And I have to figure out the b value to put in my equation. I think we did this last time, right? The period formula for sine is 2 pi over b, and our period is 2 pi. So can anyone figure out what the b value should be to make it come out to be 2 pi? Yeah, I think we need to make the b value be a 1. Okay, so the period is 2 pi, the b needs to be a 1. All right, how about amplitude? Looking at the amplitude of this graph, how high and how low did it go? It went up 1, down 1. So the amplitude is 1, so the a value will be a 1. Okay, how about the phase shift? I know that a sine graph does not start at a high. We can't say he's starting here. Sine curve starts in the middle. You've got lots of choices for this. You could say, oh, he started right here and went up, down, down, up. That could be a starting point. Some people say, I don't like going negative, I like going positive. He could start here. Maybe it started here and it was reflected over the x-axis, started going down. Some people don't like that either. Some people say, oh, what if we start here and it starts positive? Okay. The point is there are many, many ways to start this since it's periodic, and all of you would be correct if you write it the right way. So the phase shift has lots of different options. Any of these would work. You just have to write one correct equation. You don't have to write all of them. There is no up-down, so we don't have to worry about that one. I'm going to start by doing this one right here. So y equals, the amplitude is 1, so the a goes out in front, 1 sine, the b value is 1, and then we'll have x. Let's see, if we shift to the left, that would be plus pi over 2. And it would start going up, so we don't need any reflections. For people that wanted to start here, okay, a lot of things are going to match. You're still going to have the 1. You're still going to have the sine. You're still going to have a b value of 1. Except if you want to start shifting to the right, you're going to say minus pi over 2. Now this equation, actually, since it starts going down, would need a negative out in front. You also have this third option, okay? So that one would have a positive 1. You don't even have to write that. Times the sine of shifting to the right would be minus 3 pi over 2. You don't have to make all 3 of these on the test. You just have to come up with 1. Okay? I'm going to write lots of options so everybody can see if they have one that they would have chosen. Okay, cosine curve. Let's see. Let's do the period first. Down, up, down. Okay, so that's one complete cycle. And I notice the period is 2 pi. If the period is 2 pi, the b value must be what? 1. The amplitude here, the amplitude is also 1. So our a value is going to be 1. And let's figure out where a cosine curve could have started. Okay. So far we have y equals, this is a cosine curve, cosine of x. All right, let's see, cosine usually starts at a high or a low. Oh, what if it started right here? What if it started to the left, up there? Down, down, up, up. That's a good start. That is shifted to the left, so we would say plus pi over 2. Okay. Some people don't like shifting left. We also could have started our cosine curve right here. You could start at a low, okay, but then you'd need to reflect over the x-axis. So negative cosine, and if you shift to the right, that would be minus pi over 2. You also could have started here. Could have started there, shifting to the right at a high. Y equals cosine of x. Shifting to the right would be minus 3 pi over 2. Lots of options since they're periodic. Tangent curve. Okay, tangent has a different formula for period than sine and cosine. Okay, so let's see if we can figure out here. The period, one branch of a tangent is a period. So here's one period right here. And it goes negative pi over 2 to the left, negative pi over 2 to the right. So the period is pi. The formula for the period of a tangent graph is pi over b, and the period here is pi. So what should we make the b value? We should make the b value be a 1. Okay? I don't see any stretching or shrinking because there's no dashed lines, and I'm never going to make you make up a stretch or a shrink. So there is no stretch, which means the a value is just going to be a 1. Is there any reflection going on here? Oh, yes, there's a reflection over the x-axis. Absolutely. Okay, so let's go ahead and get started. Y equals, we've got 1, and then we've got tangent of, okay. Oh, what about our reflection? We've got a negative. And does a tangent graph start right there? Usually. It usually does. So I'm not going to shift it at all. We're just going to keep it a negative tangent graph. But it could have started over here. So what would that have been? Negative cotangent of x shifting to the right would be minus pi. Oh, it could have started over here, shifting to the left. It would still have the reflection, but instead of starting on the origin, if you shift to the left, that's going to be plus pi. Okay? Are these all the answers for this tangent graph? No, because it's periodic. Look, there's many, many more. I could keep going and draw. You could have started way over here. There's infinitely many answers to writing this equation. We usually just stick to the simple one that we see. Okay. Finally, cotangent. Cotangent has a very similar formula to tangent for the period. So let's take a look here. One period, it looks like a period is going from negative pi over 2 to pi over 2, so that is a distance of pi. So the b value is going to be 1 again. There's no stretch. No stretch. Okay. I'm never going to ask you to write an equation with stretch, because you just have to make it up. Is there any reflection? Nope, no reflection. Okay. How about shifting up or down? Shifting up or down. So it looks like the middle for this graph is right here. Here's the middle. Here's the middle. So it did get shifted up. It got shifted up 1 unit. Okay, let's take a look at this equation right here. So we've got y equals, we've got a 1 for a, so cotangent, we've got a 1 for b. So now the question is, does cotangent usually start on the y-axis? No, cotangent usually starts with an asymptote. He usually starts over here. So where is his starting asymptote? Maybe it's over here to the left. If it's to the left, we're going to say plus pi over 2. There's his starting asymptote. Or maybe this is his starting asymptote. Y equals cotangent of x minus pi over 2. Oh, but wait a minute. What about the shift up 1? Shift up 1, so outside the parentheses. Either way, you would have to have a plus 1 for the shifting. Some things are going to match. Everybody's going to have 1s for A and 1s for B, and the D value. It's the shifting that's not going to be the same for everybody. Okay, can you write the equation for all the 6 trig functions? Can you write equations? Can you graph them with vertical translations and phase shifts? Okay, we're doing everything now. Thanks, Pre-Calc.